Virtual reality is a heavily researched field with applications in a large number of research topics, but largely known for the entertainment industry. Optimizing rendering has been around since the last decade, and finding the optimal rendering optimization for VR is still being researched. Many scholars have investigated how foveated rendering can be used to optimize computational power with success, but no one has explored how it affects immersion, which is an important aspect of virtual reality. We sought out to investigate how foveated rendering can be used to optimize computational power and also maintain or create immersion for the users. Using the HTC Vive Pro, we created a virtual environment using the Sun Temple asset pack from the Unity store. The scene has been edited to create a more linear exploration path for the users, but still allow them to explore freely. Using the Vive Foveated Rendering plugin in Unity, we created 3 parameters for foveated rendering to understand if foveated rendering would affect immersion, and if so, how much foveated rendering can be implemented before it disrupts immersion. We created a hypothetical test with hypothetical test results, since it was not a possibility to do the test for real. We tested on 4 hypothetical groups with 30 participants in each. 3 of the groups tried with one of the foveated settings, and 1 group acted as a control group and tried the environment with no foveated rendering. Using a one-way independent ANOVA test, we wanted to see if there were any significant variance between the 4 groups. We presented the results as a hypothetical evaluation with the null hypothesis. Foveated rendering does not affect immersion. From the ANOVA test, we found the p-value to be 0.68. which is higher than 0.05, and we can therefore not reject the null hypothesis. The variance of the ANOVA test is low, which means there is no meaningful difference between the groups. Since these results were randomly generated, doing the test for real might yield other results. To conclude, the limitations set by the Danish government forced us to generate our own results for the test. Therefore, much more data is needed to fully conclude anything. Foveated rendering has the potential to be the future for rendering in VR, but it requires eye tracking, which for the moment is only available in the HTC Vive Pro. From the hypothetically generated results and methodology used, it can be concluded that there are no significant changes to immersion based on the level of foveated rendering, but since these results are hypothetical, the groundwork made here can be a leeway to fellow scholars for future work.